On number 2, we've got another 4th degree polynomial. It's just like the one from number 1, but there's a negative sign out in front. So you may already be able to guess what's going to happen. If you just took all the y values from number 1 and put a negative in front, that's what you would get here. So that can also tell you what the shape is going to be. It's going to look just like the shape for number 1, but instead of opening up, it's just going to open down. So if you take number 1 and you reflect it over the x-axis, you're going to get the graph here. But I'm going to go ahead and fill in the whole table and plot all of the points. So I chose a similar scaling system here to the one that I chose for number 1. But here my y values actually don't go up to positive 16. They only go up to 0, but they'll go down to negative 16. Don't judge me for my drawing skills. I won't judge you. So I plotted negative 2 comma negative 16, negative 1 comma negative 1, negative 1 half, negative 1/16, 0, 0, 1 half, negative 1/16, 1, negative 1, and finally 2 comma negative 16. And the shape shouldn't look surprising. So for the shape of this graph, this is kind of non-standard, the names that I'm giving to these, but I think it's good to think about what the shape looks like. So the first way to describe it is, again, just an even degree polynomial. So you've got x raised to some powers, maybe multiplied by some numbers, and then added or subtracted. You look at the highest power of x, that's called the degree of the equation. So here the degree is 4. Since 4 is even, I already know that this graph should either open up like a parabola or open down like a parabola. But if there were more terms after the x to the 4th, it could wave up and down. And then we've got the y-intercept. As you go out to the right, y decreases, and out to the left, y decreases as well.